Okay. Again, good morning, good evening. I started recording this session. This is our first class actually. Anybody has any questions before I move on with my discussion? Any questions? You can ask any questions. If you have any questions regarding training or any questions that you wanted out of demonstration or anything related to technology.
Hello, excuse me.
Yes, yes, Likita.
I'm speaking.
Go ahead, Likita.
I have a few doubts regarding Scoop, Flume, and OZ and Zookeeper, sir. Can you repeat those for me?
Yeah, we are going to do that one.
Yeah, thank you.
Thank you. Okay. We are going to cover completely whatever you said, all those echo components we are going to cover completely. Okay, 1 minute. Okay, 1 minute. Yeah. Okay, sorry about that. I got a call in between. Okay, that's fine. So someone is asking like, I mean, about my experience and all, how many years of experience I have, where did I work and all. So let me just let me introduce myself within 3 to 4 sentences. Okay, this is Shiva. I have total 9+ years of experience in IT. Out of that, I started my career as a Java developer, and after that, I worked as a mainframe developer for 5 years. And from last 3 years, I am working as a Hadoop developer. Okay, I am from Hyderabad, and apart from the job, I do have a online training experience as well as classroom training experience also. I have conducted many classroom trainings within my organization, especially in Hadoop. I've trained many people, and also online classes. This is not my first batch. I have completed many batches, and I'm able to place the students in project. Actually, mostly the students what I teach them from my United States only. They are out of just masters or people who wanted to learn the technology, Hadoop technology, other than whatever they are doing currently. Okay, so I have trained them, and I'm able to place them in a project successfully. Other than that, I'll be helping out in creating the resumes. Okay, like first after we are done with our trainings, I'll be helping out how to create the resume, what would be the keywords that we can have in your resume so that it will be having more weightage for your resume. On top of that, I'll be helping you out how to prepare the interviews. Actually, if they are asking any tricky questions and all, I will be helping you out. This is a part of training, I would say. You can always, students will always call me and ask me in between, if any project is coming or anything, something in between, they have the interview, so they can always call me and ask me if they have any questions. Okay, so this is all about myself. And other than these trainings also, I do support for the projects. Okay, I do support for the projects also as a freelancer. Anything you wanted to know about me? Sudha, are you okay? What kind of project you performing that one? Yeah, I cannot share probably about my project information, but definitely I'm going to give my real-time experience that I'm doing right now in my project. I'm going to share with you all. So I'm going to give the real-time example only as we go on with our classes. You don't have to worry about that. Okay. So you are going to get the same feel of how the real-time people are going to get the feel. You're going to get the same thing if you're able to complete the use cases that I'm going to give it to you. Okay. What's this? Will you give any homework? Yes, that's what I said. I will be giving the use cases for each and every echo component as we complete. And by the time you complete, I mean, again, every day we are going to meet 1 hour 15 minutes every day. And after that, you have to spend at least 2 more hours on whatever topics we have discussed on the day. And on top of that, if you're spending 2 more hours, definitely you're going to learn this Hadoop technology like anything. That is what I would say to my students, and that's how they learn, and that's how they are able to get into the projects. Okay, yeah, we are going to provide the use cases for each and every echo component that we are going to discuss. Without that, we don't move further. Okay, and also I'm going to show lively. Since I'm going to share my desktop, I'm going to open my Hadoop cluster. I'm going to show you how to perform each and every task, how we do in the real-time environment. Okay. Okay, so let's move on. So just we have discussed about in demonstration, we have discussed about the big data. Okay, what is big data and how IBM has defined big data in terms of 4 V's. Okay, volume, velocity, variety, and veracity. So okay, so you should be able to answer this one very thoroughly. Okay, and also we have discussed the challenges that we have using existing computational techniques. Okay, so the two major challenges that we have is storage wise. Okay, we are unable to store the data that we are getting from source to destination, even though we are able to manage, somehow we are able to manage the storage wise, but to process the data that you are getting from different sources into your warehouse, that is really difficult to process or analyze the data. So to resolve those related issue, Hadoop came into the picture. Okay, so Hadoop is the open source framework which is intended to resolve the big data related issues in terms of storage wise, in terms of processing wise. Okay, that you have to understand very clearly. Okay, and why Hadoop? We have seen this one. Hadoop is having many features, like it can collect the data from various sources, log files, image files, and I mean log files or servers or probably sensor data from the plane, and from wherever you think it can collect the data and process the data. Hadoop can collect the data from different sources and it can process. And these are the best features Hadoop is going to have. That is the reason we have to use Hadoop to resolve your big data related issues. Okay, and the beautiful feature that Hadoop has is, the special feature actually out of Hadoop framework is it can store the data in commodity hardwares. Okay, in terms of equipment purchasing for your organization also will be very less in terms of storing your data, and it is scalable. What I mean by scalable here is nothing but as you have a more data, you can add more computers to the network. We have seen that one thoroughly. Okay, and we have seen the challenges of using power of using parallel processing, that you have to understand very carefully, and challenges of using parallel processing also we have seen. Okay, Hadoop will be having two echo components, HDFS and map. I'm just going through very quickly. This is because we have already gone through very thoroughly in our demonstration. Just to recap or to get into this Hadoop mode, I'm just going through one by one. Okay, so if you just stop me if you have any questions. Okay, you can always stop me and ask me the question if you have anything. So HDFS file system is the one which we'll be using to resolve your storage related issues in terms of big data, and the MapReduce is the one which we'll be using to resolve the process oriented issue. Okay, whatever issue that we have related to process wise, we are going to resolve using your MapReduce one. Okay, and you will be having, this is the typical Hadoop HDFS cluster. On top side you will be having the master, and under that you will be having the slave computers. So as you know, client will be assigning some work to your master. Master is the one which is going to distribute that work. We have seen that finding out the maximum temperature example very clearly, like your boss is going to assign to you and you are the one who is going to assign that work to people. Those workers has to get the data and get the data whatever is there, and they have to keep with them, and they can perform the task whatever you are assigning that. Okay, in our example last we have seen finding out the maximum temperature. By whatever page they have with them, they have to find out the maximum temperature out of this. But tomorrow you might be giving another task on top of the data. You might be giving finding out the average temperature out of that page. Still you have the data, still that page is there with their worker, with your worker. Okay, they can perform those kind of operations also. It can perform anything, whatever you are assigning to whatever you are assigning the task to your worker, it can perform anything on top of that page. That's what you have to understand. Okay, so with this knowledge, and also Likita was asking, I think, okay, this is the echo component that we are going to discuss thoroughly. Okay, I did not put here Flume, but we are going to discuss Flume thoroughly 100%. Okay, so with this knowledge, let's move on with our discussion. So as you know, the typical office grade environment, okay, just don't take it as a granted. This is one computer will be there on the top, and one more computer. These are the slave computers. Okay, these are the workers that I have under me. Okay, so I'm having 4 workers. Okay, 1 master. Okay, so in our Hadoop framework, we'll be calling this one as a master node. What is node actually? Node is a computer. Okay, master node is the one who is going to assign the work to your slave computers. Who are these? These are the slave computers. These are the work computers. These are the data nodes. All these are meanings are going to be giving the same thing. Okay, slave computer, slave computer or node, both are same thing. Okay, so you have to understand node is a computer actually in our computer language. Okay, slave computer, data node we'll be calling as a data node, and we'll be calling as a work computer, work node, worker node. So these are the names are going to refer to the same thing, this one only. Okay, so these are all names are going to refer to your data node 1, data node 2, data node 3, data node 4. Okay, and here is the master one. Okay, so this is what Hadoop cluster. Okay, this is what Hadoop cluster. So can you, any one of you, tell me please how many nodes of cluster I have in my on my desktop? What is the cluster capacity, Hadoop cluster capacity here?
5.
Excellent, 5. That is a good. Yeah, that is 5. Why Sudha you said only 4? Okay, whenever someone is asking what is your Hadoop cluster capacity, the answer should be including your master you have to count. Okay, that's good Sudha, but including your master you have to count that. What is your Hadoop cluster? You should say 5 node cluster. This is a 5 node cluster. So in that they might be again asking how many data nodes you have. What is data node here? 1,
4.
okay, so 4 data nodes, 1 master node. So including this, so you have 5 node cluster you have in your Hadoop cluster. That is good. So far you are able to understand this one. Okay, so now in our example, probably finding out the maximum temperature, we have seen probably you are going to, you are the client here. Okay, remember client is not part of your Hadoop cluster. Client can be anything outside. From one computer you are going to submit a job, or you are going to copy so and so data into your Hadoop cluster. Okay, client is not a part of your Hadoop cluster. It can be, but it's not, it's always not recommended. Okay, you cannot have. Okay, so you are trying to copy the data and from so and so data, probably temp.txt, this temp.txt file is having 100 MB. Okay, so you are trying to copy this 100 MB of data into Hadoop cluster. How it is going to act, we are going to see now. Just concentrate here, how it is going to act, how we are going to break it down. Because in our finding out the maximum temperature example, what we have seen, whenever you are getting 10 pages of work from 10 pages from your boss to you, what you are going to do, you are going to distribute each page to the each worker, and you are going to do. Then what do you mean by each page? How you are going to decide one page you have to give to the one worker? Why not 2 pages to the one worker, or why not 5 pages to the one worker? So how you are going to decide that one, we are going to discuss here. Okay. So in that example, what you did, you distributed, you divided your whole data, you cut it down your whole data into chunks of data, and each part you have stored with your one worker. The same way here, what you do here is, whenever you are going to copy 100 MB of data or 1 terabyte of data, whatever it is, okay, what you do, you are going to divide this whole data into number of pieces. That we are going to see how you are going to divide. But for example, I would like to divide each chunk of data size is 100 MB. I mean, data, I'm going to divide at a 10 MB of data. I'm going to store that data. Okay, I'm going to store. I mean, let's go for the example as a 4 MB. Okay, divide as a 4. Okay, in order to divide into 4 times, probably I will go with the 25 MB each. Okay, I will let you know how we are going to decide this, how we are going to have each piece as a 25 MB. But as of now, I am going to divide my whole 100 MB of data into each part as a 25 MB. And how I am going to store that one? You can see that one. Okay, 1 minute. I will connect for continue for now. Okay. Okay. So now we are going to divide into some number of parts, 100 MB of data. Let's see how it's going to. Okay. If you are going to divide 100 MB of data into 4 parts, each piece will be having how much? 25 MB. Okay. Probably 25 MB. I'm going to store the sum to one part here, one more part of data here, one more part of data here, one more part of data here. So each will be having 25 MB. 25 MB, 25 MB, 25 MB. Okay, so this is how I have divided my whole data set and stored in this one. So what I did here, I have distributed my whole data into my Hadoop cluster. So here you have to understand, even though in our finding out the maximum temperature in our demo example, did you store, I mean, whenever your client is assigning the work to you, did you have any pages with you? When you are distributing work to your workers, did you have any pages with you?
No.
No. That is good. No. Why? Why? Because you have distributed your all pages to your workers. You are asking them to go through those pages. The same way here. So that concept you have to understand here. Your master node is not going to hold any data. What it does is, it's going to get the data from your client and it's going to distribute the data to your data nodes. Okay. So this is a main important question for your interview. Master node is not going to hold any data. It is going to get the data from your client and it's going to distribute across your data nodes. That's what you have to understand. Okay. So now what is data node here with our concept? What is data node? Data node is the one which is going to store your actual data. What is worker node, slave node, data node? It is the node which is going to store your actual data. That is what you have to understand now. Are you clear about what is data node? Data node is a node which is going to store your actual data within your Hadoop cluster. Okay. So now with this knowledge, let's go on and continue. Like how I am going to divide, how I'm going to say this my each piece size would be 25 MB. Why cannot 50 MB? Why cannot 1 MB? Okay, so that is there. Okay, so let's discuss on that one, how we are going to have. So this whatever I am saying, this one 25 MB is whatever I just decided as a 25 MB. This will be calling as a block size actually. What is mean by block size here? Block size is nothing but the amount of data that your Hadoop framework is going to read or write into your HDFS file system. What I am doing, out of whole 100 MB of data, I am going to divide each block size as a 25 MB, and I am going to store each block into one of my data node. So here in my example, I have divided into 4 blocks. Okay, so 100 MB of data is divided how many blocks? Block 1, block 2, block 3, block 4. Okay, so block 1 we have stored here, block 2 has stored here, block 3 has stored here, block 4 has stored here. So what is block size here? That is very important question. What is the block size? The amount of data, okay, the amount of data that your Hadoop framework is going to read or write into your HDFS file system. Okay, that is what block size. Okay, now the next question is how we are going to decide this block size number. Okay, this block size is configurable. What I mean by configurable is, in one of your Hadoop framework configuration file, you can set this number. Okay, whenever you are trying to copy any data from external sources into your Hadoop cluster, probably 100 MB, 1 terabyte, 15 terabyte, whatever size the file size is, what you are going to say, hey, I would like to divide this whole data into number of blocks, and each block size is 25 MB. Okay, let me complete this one. After that I will answer your question. Just keep on ping me whatever questions you have. Okay, so I am going to say my each block size would be 25 MB. So that's how I am going to put in my configuration file. Okay, one of my Hadoop configuration file, I am going to say, hey, my default block size would be 25 MB. So if I am not specify anything, whenever I am copying the data from external world into my HDFS file system or into my Hadoop cluster, the default block size will be block size will be considered, and that is how your whole data will be divided. So I am saying here 25 MB here. Okay, in my configuration file I set the block size as a 25 MB. This can be configurable, it can change anytime. So our default Apache Hadoop configure block size is 64 MB actually. So what I mean by 64 MB here is, so if I am not going to change anything in my software when I am installing my Hadoop software, whenever I am trying to copy this 100 MB of data or probably 5 terabytes of data, my whole data will be divided into chunks of data. Each chunk size is 64 MB. So in this case, how many blocks of data I am going to see if I am going to have a 64 MB as a block size? Can you, any one of you answer me? If I am going to divide this 100 MB of data into number of blocks, each block size is 64 MB, then how many blocks of data am I going to get out of this temp.txt file which is having 100 MB? Why did we store block size? Okay, that's good. Yeah, go ahead.
No, actually I didn't understand, so I'm saying no.
Okay. You did not understand the question? Or
yeah, can you repeat it again? Sorry.
Yeah, no problem, you can ask me. The question here is, I mean you understood what is block size, right?
Yeah.
The block size is the amount of data that I'm going to read, or I'm going to divide my whole data in chunks of data. Each chunk is going to have what is the size. Okay, that is the block size. Okay.
Yeah.
Now my question is, here in our example, my temp.txt file size is, okay, my temp.txt file size is 100 MB. Okay, let me write it down, equal to 100 MB. Okay, and I've set the block size as equal to 64 MB as a block size. Then how many blocks am I going to see out of this 100 MB of data?
Four.
Okay, 4. Why do you think it is 4?
Because we have 4 data nodes. So
Yeah, that's perfect. Yeah, let me tell you this one. So how many data nodes you have? You're not going to divide that many parts. Okay, here our concept is the whole file, whatever it is there, you have to divide by your block size. Indirectly you are going to get how many data nodes. Okay, if you divide 100 MB by 64 how much you get? The whole number 2, right? So you are going to have a 2 blocks. Okay, block 1 is equal to 64 MB, and again block 2 equal to how much? Remaining 36 MB.
okay.
So based on your data nodes, you are not going to divide how many blocks you are going to get out of your file. Based on your block size only. Whoever answered 2, that is perfect. That is good. Thank you. Okay, whoever answered 2, that is good. Okay, so you are going to see 2 blocks of data. Block 1 is having 64 MB, block 2 is having 36 MB out of this 100 MB of data.
Okay.
Okay, got it? So,
Yep.
okay, and with that, Likita is asking why you have to store the block size in different data nodes. That is good question actually. For example, the whole purpose of having your Hadoop framework is what? To achieve the parallel processing, to achieve the distributed computing. Okay, what I mean by distributed computing? Instead of storing in a single computer and getting what I wanted, instead of storing in a single computer 1 terabyte, 10 terabytes of data and computing on top of this one, what you have to do? You have to distribute the 10 terabyte of data across more than one computer, and we are going to ask each computer to work on that one. So instead of taking 10 hours to compute the data, if you are going with the 2 computers, it might be coming down to 5 hours. If you are taking more than 2 computers, it's going to probably, if you are taking 10 computers, you are going to end up 1 hour only. If 1 hour, one computer is working on 10 terabyte of data, you might be taking 10 hours. But instead of you are going to have a 10 computers, you are going to have only 1 hour. That is the power of parallel processing that we have seen in our demo class. Okay, here for example, even though this data node is having enough storage to store, okay, let's go with this example. Okay, so now with this example, let me put different color. Okay, my default block size is 64 MB. Block 1 and block 2 is there. I'm going to store block 1 as here, block 2 as here. Okay, with our Hadoop concept, just think as of now. Okay, now block 1 is stored here and block 2 stored as here. How we are going to decide block 1 has to be stored in data node 1 and block 2 is stored in data node 2? That we can discuss. That your Hadoop framework is going to take care of that. But in coming classes, we are going to discuss how you are going to decide. But as of now, why you have to store? Your data node is having enough space to store your block 2 also. Okay, your data node is having enough storage. Probably this hard drive is 1 terabyte of hard drive. It has just occupied only 100 MB of data or 200 MB of data. Probably 200 GB of data it has occupied, and rest else is free. Still, you can, your data node 1 can occupy your block 2. So, but your Hadoop framework is not going to store this block 2 in data node 1. Why? If you are able to understand this one, Sudha, you should be able to understand your question. Okay, why I am not going to store my block 2 in data node 1 even though I have enough storage to store my block 2 here is, when I am going to store my block 1 and block 2 in the same computer, and whenever I get the request to process on top of this data, what it is doing indirectly, only single computer is working on my whole data. My 100 MB of data, on my 100 MB of data, only single computer is working on this my 2 blocks. So you are not going to achieve really parallel processing here. Only one computer is working. That is the same issue that we have seen in the existing computational techniques, Java, mainframe and all. Okay, so that is the reason, even though you have enough storage to to store your R blocks out of one file, your Hadoop framework is going to distribute to more than one computer. That is the reason only you are going to get the power of parallel processing. Otherwise, you don't get it. Yeah, that is one more thing. But that we are going to discuss. That I mean, she is asking, Sudha is saying, even if you have the data lost, we lose the whole data. That is there. When we are going to discuss about replication factor, that we will discuss thoroughly. But as of now, you have to understand, whenever you have even those free space to store your whole data in single data node, but your Hadoop framework is not going to do that way. It is going to distribute your block across the data nodes to come or to use the power of parallel processing, to use the power of distributed computing. Okay. Okay. So just stop me if you have any questions. Okay. Let's move on with our discussion.
And just I want to share something here. So
yeah.
You have told me like for Hadoop it will be default size is 64 MB, right?
Yes.
But I have read in something like it depends on the distribution you use also. For example, if you're using a Cloudera sandbox or something like that, so it is 64 MB, but it has improved now from 64 MB to 128 MB. So
okay. Yes.
Depending on your distribution, you should actually know what block size would that be.
That's good. Excellent. Yeah. So probably I need to talk about distributions. Probably just 1 minute. In a minute, I would like to close that one. The distributions are nothing but this Apache Hadoop is an open source framework, which is nothing but you can get your source code out of your Apache Hadoop and you can customize however you want. But since it is an open source framework and you have open source system, you are not going to pay anything for that. At the same time, you are not going to pay anything for them. You are not going to get any support if you are stuck in between. If your system is not working, the same way you are not going to pay anything for them. So now, what do you mean by distributions here? People who don't know about distributions are nothing but probably you got your this Apache Hadoop source code and you customize them. You made some of the cosmetic changes on top of that. You made a software. Okay, the base for this your distributions is Apache Hadoop only, but you made some of the things changes in that, and you are giving that product to your organizers, saying that hey, if you are going with Apache Hadoop, plain old Apache Hadoop software, you are going to get the software, but you don't get any support. Okay, you have to maintain your own cluster with your own expenditure. Okay, you have to have a certain employees to maintain that one, admins or developers, whatever it is. But whenever you go with the distributions, people who have customized this Apache Hadoop and whoever is giving the product to you, they say, hey, we are going to give this product to you. It's going to work same as Apache Hadoop because the base is Apache Hadoop only for them. Okay, so they said, okay, we are going to give this one to you and you can use this one. Along with this one, we are going to provide the support also for you. If your cluster is not working or if one of your data node is going down, so that time they are going to provide the support for that one. Okay, so at the same time you have to pay for them. I mean, without paying anything, they could not support for you. It's kind of, that is called distributions. So in our market, we have many distributions: Cloudera, Hortonworks, Mapper, DataStack. These are the distributions that we have from Apache Hadoop side. Okay, you can use either one. So they have customized your Apache Hadoop and they are going to use them. So here, based on your distributions, they can set the default block size also. Okay, because 64 MB probably small in size, now we have reached in petabytes of data, they have decided to go with 128 MB as a block size. You can go with 256 MB as a block size. As you increase the block size, you are going to see one issue here. What is the issue? Again your block size is going to be increased. Again indirectly to process the data or to store the data also, it will take some time because it has to, the block has to transfer over the network from here to here, then here to here. Okay, that is the reason it's always recommended to go with less block size, but always, I mean, that is the reason Apache Hadoop has came up with a 64 MB. Yeah, distributions, they can have their own, 128, 256, however they want. This is a default. This is not a fixed one. This is a configurable. That's what I said. It can be configured. Okay, in one of the Hadoop configuration file, it can be configurable. That is the whole story about distributions, and it is default block size. Yes, Kirti? Yeah, the distributions default block size is 128 MB. That is there, but don't take it as granted. But you can change anything, whatever you want. But we are going to probably till 50 to 60% we are going to learn about Apache Hadoop, because that is the basic. That is the base for your all distributions. The concepts, the command that we are going to issue here, everything is same on your distributions also. But you have to get the first Apache Hadoop flavor. Then only you have to learn about distributions. If you are directly learning distributions, these core concepts or these basic concepts that we are going to learn about Apache Hadoop, we are not going to learn. Okay, so let's concentrate about Apache Hadoop, then we can move on to distributions after we complete 50 to 60% of course. Okay. Okay, so let's move on with our topic. Is that clear, Kirti? Did I answer your question?
I think it is Sudha who asked the question.
Oh, sorry. Okay. Okay, Sudha. Okay, Sudha, are you clear? Okay, thank you. And also Naveen is answering, Hadoop will make 3 copies in different nodes. So there are, okay, this is too early, Naveen. Let's park this one aside. Okay, people who are going to, who did not know about this replication factor and all, I may confuse them. Probably we can discuss as we go on with our classes. Okay, as of now, this is the story behind the screen. Okay, so let's move on with our discussion. Okay, so let's discuss few things about the parallel processing. Okay, so here the first point that I put here, let me copy into Paint and explain one by one. So here my first point is performance should degrade gracefully with the partial failure of the system. So what I mean by this one here is, so in our example, you can see in my example here, so you have a 5 node cluster, and I'm trying to find out the maximum temperature on top of this 100 MB of data. Okay, so on this one, probably my entire Hadoop cluster is taking probably 10 minutes. Okay, 10 minutes of time to compute maximum temperature out of this, maximum temperature, to find out the maximum temperature out of this 100 MB is taking 10 minutes of time. So now probably my 2 of my systems are not working in my Hadoop cluster. 2 of my data nodes are not working in my Hadoop cluster. Okay, what I am going to do now, probably my only with these 3 computers I am going to compute my things, and I am going to get it the results back. Okay, don't worry about how you are going to recover this data and all, but as of now only 3 computers are working instead of 5 computers. So now how much time it will take as well, actually as per the rules, as per the Hadoop framework, as per the parallel processing concept, if my 5 computers are taking 10 minutes, if I have only 3 computers, probably it should take only 5 minutes. Okay, that does not mean that, I mean, I'm sorry, I did the reverse way. Okay, okay, if my 2 data nodes are working, I mean only 2 data nodes are working out of 4 data nodes, probably it should take 15 minutes. Okay, it does not mean that if my 2 computers are not working in my Hadoop cluster, it should not take 50 minutes of time. Okay, it should not, that the time taken should not be this much difference. Okay, so if my 5 node cluster is working, only 10 minutes I am taking. If my 2 data nodes are now working, probably 15 minutes. It should be always proportionate. That's what I meant here. The performance should degrade gracefully. It may go down as a proportionate, not like a spike. Okay, okay, this 10 minutes is taking with the 5 node cluster. If one of your computer is not working out of your 5 node cluster, it should take 50 minutes or 60 minutes. That is not the case. Okay, the second thing is failure should not result in loss of any data. What I mean by this one here is, if my 2 computers or 1 computer is not working out of this 4 data nodes, whatever data I have in this computer, I should not leave for my computational techniques. I should not leave to create the report out of this one. To this 25 MB of data I should not skip, and only this 25, 25 and 25, some 75 MB of data only I'm not going to run my logic and find out the maximum temperature out of this one. Okay, that should not the case. What I have to do? I have to recover this data. I have to recover this data and I have to compute. I have to run the logic on my 100 MB of data. Okay, that is what I mean. Okay, failure should not result the loss of any data. Okay, you have to recover this data and then only I have to compute on top of 100 MB of data. Okay, the third point is recovered component should be able to rejoin the system without needing a reboot. What I mean by this one here is the same thing here. If these two computers are going down and your admin is coming and is fixing these two computers, now they are ready to rejoin them back to your network. Okay, if that is the case, I should not again bring all these computers down, which is nothing but I should not bring my whole Hadoop cluster down and then only I should be able to rejoin this one. If I am doing that one, there are lot many interventions or there are lot many delays in my production grade environment. When I have 5,000 or 10,000 node cluster, at any point of time one of my data node might be down. So if that is the case, if I want to rejoin them, I always need to bring my I have to bring my Hadoop cluster down, then only I can rejoin them. No, that is not the case. You should able to rejoin them automatically without rebooting your entire Hadoop cluster. Okay, that is the concept. Okay, so that is what mean here. Okay, recovery component should be able to rejoin. That's what the meaning of here. Okay, partial failure should not affect outcome. Okay, that's what we have discussed already. So if one of my computer is going down, okay, this 25 GB of data I should not leave, I have to recover. If I am leaving this one, okay, indirectly whatever it is there in this data I am not going to consider to come up with the maximum temperature out of my 100 MB of data. So I have to recover this data and I have to compute this one. Okay, that is the meaning of partial failure should not affect outcome. Okay, so are you clear with these points? This is mainly we have to concentrate. I mean, these are the rules when you are going to have the parallel processing. Okay, the continuation of whatever challenges we have with the parallel processing. Okay, so our next topic is Hadoop history actually. Okay, any one of you know how Hadoop came into the picture, how we named Hadoop and all? Can any one of you please go through quickly if you know about that? Probably within 2 to 3 sentences. Okay, I mean I will be asking questions in between so that our our class will be a little bit interactive so that we can listen properly. Okay, yeah, Hadoop is the name of tile. That's good, perfect, Sudha. Okay, any more questions? Any more answers? Okay, so let me start with this one. Okay, so how we got this Hadoop product and all into our market? Let's discuss on that one. Okay, so in 2002, Doug Cutting. These are the two people, Doug Cutting and Mike Caffarella. Let me twist this one. Okay, Mike Caffarella. Okay, people mostly they will be saying about Doug Cutting only, but Mike Caffarella also is a part of this project who has started initially on working on this product. Okay, Doug Cutting and Mike Caffarella in 2002, what they did is as a part-time job. Okay, as a part-time, they did not work on as a full-time. Okay, after their job hours, okay, what they did, they started working on one project which is called Nudge project. Okay, which is a Nudge project, which is a search engine actually. Okay, search engine, open source system. Okay, what I mean by open source system, people can get the source code and they can modify, they can customize however they want. But in 2002 we have already Google. Why we have to talk about, why we have to get the search engine again? Why? Because Google is a paid one. You have to pay some money in order to customize that one. So that is the reason Doug Cutting and Mark Caffarilla, what they did is, hey, why can't we go ahead and use open source, or open source probably Linux here in this case, Linux. We can using your Unix or Linux, using your Unix, I'm sorry, Unix, using your Unix, why can't we build one product which is a search engine people can use, can customize without any cost? Okay, that's how they started. Okay, so they started and they started using this parallel processing, because using one computer they cannot accommodate whole data whatever they have. So what they did is they started clubbing these 20 computers together, and they started working on that as a part-time job. So in 2004 they are able to, the first cut is ready, and they are able to implement this 20 node cluster, same thing, 20 node cluster with this nudge project. Okay, 20 node cluster, they are able to success, they are able to store the data, they are able to get the data out of each computer, and they are able to process that one in 2004. Okay, that is well and good, but it should not stop with the 20 nodes, right? They should not stop with the 20 nodes. Okay, so what they did is they tried to add 40 node cluster, 40 nodes to the cluster. Okay, when they added 40 nodes to the cluster, when they increased 20 more nodes to the cluster, they added 20 more nodes to the cluster, they are facing the difficulty. What is that? They are not able to achieve what they wanted. The processing time is going really bad. Okay, that is taking more time than what they expected. The storage wise also they are facing lot many issues to store store your data in a 40 computers. Okay, that is in 2004. Okay, they almost stuck in between. They thought, hey, we are not able to proceed further with this one, so we are going to stop working on this nudge project. Okay, so that is what they thought. Okay, in 2004. At the same time, in 2004-2005 time, okay, what Google has done is Google has released white paper. Okay, white paper called GFS, which is nothing but Google File System. Okay, and one more thing is MapReduce. Okay, these are the two white papers they have released, saying that using the distributed concept we are able to store the data in more than one computer. Using MapReduce program we are able to process the stored data in my distributed file system. That is what they wrote in the white paper. Okay, so Doug Cutting, Mike Caffarilla got those white papers, and they thought like, hey, why can't we use this concept for our 40 node cluster? Okay, so again in 2004 they started working on that, and they are able to succeed in 40 node cluster, whatever concept they have used in the GFS, Google File System, and MapReduce. So the same time in 2006 Yahoo came into the picture. Okay, in 2006 Yahoo came into the picture, and what they did is Yahoo has contributed 20 people to them. Okay, and they said they are providing 20 more people as a team, and also they are giving them more equipment to them, and they are asking them to work as a full-time job. Okay, Yahoo has contacted them, and they have given 20 more people and along with the equipments, and they asked them to start working as a full-time job instead of part-time job on that nudge project. Okay, they have started working on that. They kept on adding more nodes to the network, to the cluster, and they are able to achieve in 2008 they are able to achieve 4,000 node cluster. They are able to implement 4,000 node cluster in the production grade environment in 2008. Okay, this is the whole story, how Hadoop came into the picture and how they started working on that. Okay, in 2002 they started working on Nudge project, which is a open source search engine where you can get the source codes and you can customize that, and they are able to succeed in 2004 with the 20 node cluster, and they started adding more nodes to the Hadoop cluster, I mean to the your nudge cluster, and they are not able to succeed with the 40 node cluster. At the same time, luckily Google has released two white papers. What is a GFS, Google File System, and also on top of that MapReduce. Using your Google File System, they can store the data. Using MapReduce, they can process the data. This is the whole concept behind the GFN and MapReduce. So again, duck cutting and Macafarilla again started working on that, and they are able to succeed with the 40 nodes cluster. Okay, the same time Yahoo has approached them, and they had a meeting, and they said like, hey, instead of working you as a part-time, why don't you work on the full-time, and we are also providing 20 more people along with the equipment. Okay, they started working as a full-time job. Okay, they are able to succeed with the 4,000 node cluster in 2008. Yahoo has successfully implemented this 4,000 node cluster in a production grade environment lively for their users data. That is the whole story about how Yahoo came into the picture. Now let's discuss about how Hadoop came into the picture. So far we have seen only Nudge project, right? Then how Hadoop came into the picture. Okay, when Yahoo has approached them, the main intention for them was, I mean, before Yahoo came into the picture, the main intention was to develop the Nudge project for the search engine. Okay, but after Yahoo came into the picture, what they decided, hey, this project is not only useful just for search engine. Okay, this project will be useful for whole projects. Whoever is dealing with the big data, whoever is dealing with the more data. Whenever I say big data can be anything, 1 terabyte, 2 terabytes, 10 terabytes. Okay, whatever data you have, if your one system you are not able to compute this one, if you wanted to process the data more than one computer, you have to go with this one. So they started towards big data. Okay, they started working towards big data related issue in 2006 itself, whenever Yahoo came into the picture. Okay, that point of time they were, instead of Nudge project, they thought they can name what different name. So they were thinking, they got the different names to that, but no one agreed with that. There were many discussions on that, but at the same time, duck cutting was working on that. At the same time, his kid was playing with his toy, actually, with his elephant toy. Okay, this is the same words that has given in one of the duck cutting interview. Okay, so his kid was playing with his duck with his elephant toy. Okay, so that time his elephant toy's name was a Hadoop, actually. Duck cutting son's elephant toy name was a Hadoop. Okay, so at the same time, this duck cutting thought, hey, this elephant is actually big in size, which is representing like is a huge in size. So why can't I name this Hadoop to my product name? That symbol also, that's how he has introduced. Whenever you see the Hadoop, you are going to see the elephant symbol. Why? Because that is how it came into the picture. Okay, so that is how your Hadoop name came into the picture for this product. Okay, so later on they had a discussion within the team. They thought, okay, this is representing the huge in size and easy to remember, easy to pronounce, easy to write. That's what they decided in their team. That is how they have named their product as a Hadoop. There is no special meaning of Hadoop. There is no expansion of Hadoop. This is how they named their product name. Okay, any questions here? Any questions here?
No.
Okay, so duck cutting son's toy name is a elephant toy name, actually. Okay, elephant's toy name is a Hadoop, actually. That is how Google, but here and there, just to concentrate here. Okay, if you have any question, just ask me. Okay, so this is what I have written here. In 2002, duck cutting and Mike Caparilla started working on here, and Yahoo came into the picture. It was a primary contributor for your Hadoop product, and they are able to achieve from 20 node cluster to 4,000 node cluster in 2008. They are able to succeed that one. They are able to implement successfully in 2008 quarter one. Okay, the next thing is Java, written in Java. What is Hadoop and all? Hadoop is actually, it is developed on Linux operating system and written in Java. Okay, that does not mean that it cannot work on Windows operating system. It can work on iOS, Windows, Solaris, or whatever different operating flavors you can work. Your Hadoop framework can work on different operating system. So that's what I written here. Okay, written in Java. It's an open source framework written in Java on Linux operating system. Runs on commodity hardware. We have discussed this one thoroughly. It can runs on commodity hardware, which is a cheap hardware. Okay, you don't have to pay much for your equipments. And then the third point is it can run on Linux, Mac, which is iOS, and Windows and Solaris. So on these operating systems also you can run. Okay, nowadays Windows, I mean Microsoft is working a lot to come up with their own product which is developed in Windows. Actually, so far Hadoop is Linux, right? So they came up, they're trying to come in Windows also, where they can run on Windows based machine also. They're spending a lot of money, but still they are not succeeding that, but they are working on that actually. Okay, so this is all about Hadoop history. So okay, let me move on with my next topic. Okay, so I put a little bit one more point here. Hadoop is not just a framework, it's not just a database, it's not just language. You can do combination of all these things. Okay, Hadoop is a framework, database, and language, and technology also. It's a combination of all. Okay, we have seen data is split into blocks. We have seen how we are going to split your data into number of blocks. We have seen thoroughly in our example here. In our first example here, 100 MB of data, we are going to divide into number of blocks. We have seen here. Okay, block 1 has a 64 MB, block 2 has a 36 MB. Okay, and any questions here so far? Each computer will have one block. Each computer will not be having one block. Okay, it can have more than one block also. Okay, let me continue with this example. This temp.txt is having one file, and tomorrow I am going to copy one more file, abc.txt. Okay, this file size is having probably 200 MB. Okay, so if I'm going the default block size as a 64 MB with my Apache Hadoop, how many blocks I am going to see? Can you, any one of you tell me how many blocks I am going to see? How many blocks I am going to see? 4 blocks. Okay, excellent. Block 1 equal to 64. Probably let me put this one here. You can read here. Block 1 equal to 64. Same way, block 2, block 3, block 4. Okay, so simply in order to know how many blocks of data you are going to see out of your whole file, simply what you have to do, you have to convert that whole data into number of MBs, since you are going to divide into 64 by divide by 64. You can see 3.1, which is nothing but 4 blocks. You have to make it as a more nearest, not nearest to the upper number. Okay, 4. Okay, so you are going to see the 4 blocks of data here. So now I have to accommodate these 4 blocks of data in my Hadoop cluster, because I need to store this data into 4 blocks. So in this case, what I am going to do, I am going to put one block here, one block here, block 2, block 3, block 4. So doing more than one block from different computers, right? Your computer is storing more than one block from different files. Okay, this block 1 is from first B1 is from your temp.txt, second B1 is from that abc.txt. So as long as you have enough space to store more data in your data nodes, you can do this one. Okay, so that is what the answer for your question.
But why do we have in that fashion, like each computer or each node will be handling different types of data and it will be processing different types of data? So instead of doing that, like why can't we have in one node or some nodes dedicated to this processing and some other nodes dedicated to some other processing? Why are we mixing matching?
Excellent. So if your question is like, whole blocks in one computer, right? Block 1, block 2, block 3 and block 4 in one computer so that it can process the data. Is that true?
Exactly. Even if something goes wrong, then we can directly assume that, okay,
Yes.
this computer has gone down, that means temp.txt is the problem. We can
Okay.
directly figure it out. So why do we have this?
Yes. Yeah. Thing is, you understood the power of parallel processing, right, Sudha?
Yes.
So can you please explain me in 1 or 2 sentences why we have to use parallel processing here to process your big data?
To like to process multiple things at the same time, and like multiple data blocks we can process at the same time, and we distribute over that.
Yes. Excellent.
Yeah.
You are distributing the work. Okay. You are
Right.
distributing the whole work to the different computers. So in this case, for example, I am going to store all my blocks in one single computer. Are you going to really distribute that work to different computers?
Sorry, can you come again?
Yeah. For example, you said you are going to distribute the work across the computer and you are going to compute on top of that. You are going to make sure more than one computer. You are going to use more than one computer for your computational techniques. Okay. So at the same time here, for example, like you said, if I am going to store this all blocks, block 1, block 2, block 3 and block 4, which is my abc.txt in one data node, which is in data node 1. In this case, am I going to use the parallel processing or distributed process here?
No.
That is the reason we have to distribute these blocks across your data nodes. If you are going to store whole data in one file, really the amount of time that you are going to take is equivalent to what you do in the general whatever you have existing computational techniques, that much of time you are going to take, because your only single computer is working on whole data. Probably you are thinking like this 200 MB of data, probably they'll think about 10 terabyte of data. You have one file as a 10 terabyte of data. So if you are going to, probably your hard drive is having 15 terabyte of data. Okay, your hard drive is capacity is 15 terabyte. So if you wanted to store this 10 terabyte of data in this computer, you can still store this one, but to process this 10 terabyte of data for this computer, how much time will you take? Probably 1 day. Whereas if you divide them into the blocks, and if you are going to store each block on different computers, so your 4 computers are going to work on this 10 terabyte of data instead of one computer. Are you following right, Sudha? Okay, yeah, yes, yeah. So instead of storing entire data in single computer and making use of only single computer, even though you have a distributed cluster here, we are going to distribute each block across the data node. That is how you are going to get the parallel processing. That may be confuse you a little bit, but if you think little bit a lot, if you think through, you will understand very easily. Instead of making use, I mean, probably you have only 200 MB of data, you are thinking, okay, 200 MB of data is very small files, why can't we store in a single computer? Then for example, you have a 10 terabyte of data, how you are going to handle that one? 10 terabyte of data, if you are going to store in a single computer, you cannot really achieve the parallel processing. Okay, so let's move on with our discussion. Okay, someone has some question in between. They were trying to ask something. Okay, what was that? Please go ahead, Krishna.
No,
Each data node. Go ahead.
I have the same question as.
Okay, yeah, I am able to answer your question. Did I clear your question?
Yeah.
Okay, thank you, Naveen. Okay, each data node's computer memory is divided into multiple blocks. Each block size is 64 MB. Data nodes computer memory, yeah, Krishnaveni, we cannot really say that way. If you are dividing whole data, yeah, this is on top view, that is correct. But again, if you are dividing, I mean, what Krishnaveni's question here is, if you others are able to see our screen, what is that she is saying? Each computer's memory hard drive has divided into 64 MB, 64 MB, 64 MB, and whenever you get the any block into that, she's going to store here, okay, block 1 and block 2 here. But in this case, probably in our case, okay, 100 MB if you are taking, okay, block 1 is 36, block 1 is 64, that is fine, it's going to fit into one block, and block 2 is going to be 36, that is fine, it has sit in the second block. So remaining, how much is left here out of 64? How much left? 28, right? 28 MB of space is there in the block 2 if you are dividing that way, right? If you are going to divide this, each block has a 64 MB block size, your whole hard drive of each data node. If you are storing that way, your block 2 has stored in the second block, but remaining 28 MB of data is left ideally if you are going to divide that way. But you cannot do that. You can reuse this 28 MB of data for other blocks also. It can continue storing from where you had that block 1, block 2 has ended. That is the reason your computer is not going to divide that way, but as a top view, yes, you can think that way. I mean, if you are having equal number of block size, probably all 64 MBs, yeah, your case is correct. But if it is less than that, probably if you are having the same case, if you are having 1000 files in your Hadoop cluster, 1000 files, last block size would be 1 MB or probably 10 MB. So if you are storing 1 MB in a 64 block size, rest else 63 block 64 MB of block is wasted? No, that is not the case. That 63 MB of space will be used for other blocks also. Right, Krishnavani? Did you get that? So your entire computer's hard drive will not be divided into 64 MB. It on top view, yes, it can, but that leftover memory, leftover space will be used for other blocks also. Okay, to utilize your 100% storage whatever you have in your Hadoop cluster. Okay, so let's move on with our discussion. Okay, the next discussion here is HDFS file system pool. Okay, so now with our example, you can say this one is, what is your HDFS file system now? What is your HDFS file system? HDFS file system is to store your data. Okay, so what computers are storing your data? These 4 computers only are storing data out of 5 computers. Why? Because this 5th computer is working as a master node. It's going to take the work from different world and it's going to assign the work to your data nodes. So what is data node? Data node is the one which is going to store your actual data. So with this concept, let's move on with our one more example here. Okay, let me draw one more diagram here. So you have a master, 1 data node, 2 data node, 3 data node, 4 data nodes. Okay, so I have interlinked all together within the network, and here is my master. Here is the data node 1, 2, 3, 4. Okay, so now you can think now here. Let's talk about configuration side. Okay, so probably each computer configuration, just for our calculation purpose, okay, 100 MB. If the actual if the actual data is stored in the data nodes, okay, actual data stored in the data, if node need to search some data, how do we do that? Yeah, that we are going to discuss very thoroughly, Likita. That will come into the processing side, that we are going to discuss thoroughly. Just park that one aside. Probably after the next class or probably the 4th class, we are going to discuss that one. Okay, when we discuss more about MapReduce, we are going to cover that one. Good question, that one, but we are going to cover that one in the next one. Okay, so for our calculation purpose, I'm now going to calculate what is my HDFS file size in my Hadoop cluster. You have to concentrate here. You have to understand. Okay. Okay. This is the master node. Okay. It's too early to introduce about that name node. Okay. People who don't know about name node and all, I don't want to introduce now. Probably if you know about name node, please just it's okay. We are going to discuss. This is the master node. Okay. This is a master node and these are the slave nodes. Okay. So now my each computer configuration is okay 10 MB. Okay. 10 GB hard drive, okay, probably 4 GB RAM, 4 core processors. Okay, so this is my.
I have a doubt.
So
like initially you were actually assigning, the master node is assigning the task to slave nodes, right? So is it something like first it will go and assign it to node 1 and then to node 2? Is it something like consecutive like that, or if node 2 is busy, is it going to assign it to node 3 or something like that?
Okay, that is a good question. Yeah, that is not the way it's going to work out. That wherever you have data related to your file, those data nodes will come into the picture and act on the data. Okay, probably if I draw here, probably let's take abc.txt, temp.txt. My temp.txt block 1 and block 2 stored is here. Okay, whenever I wanted to process the temp.txt file, which computers I am going to ask to work on that, which computers your master is going to work, assign the work to your data nodes, this data node 1 and data node 2 only, right? And again my abc.txt file, this is temp.txt, my abc.txt file has 4, probably let's go only with the 2 blocks, and again still it is having 100 MB. My block 1 is stored here, my block 2 is stored here. So now whenever you wanted to process abc.txt and you send that request to your master, master is going to assign the work on to which computers?
1 and 4.
Excellent.
1 and 4.
That's how it is going to work out. Wherever your data resides in your data nodes, those data nodes only will be working on those blocks. Rest else will be ideal.
Shiva,
Uh-huh.
that is for processing the data. What about storing the data? How it will store? If D1 or D4 are busy at the time, so how it works?
Yeah, that will be Hadoop framework as algorithm for that. It is called load balancer. That is going to discuss thoroughly when we talk about read and write operations in your HDFS file system. How your master is going to decide which data node has to select to store your blocks. That will be discussed very thoroughly in our read and write operations of your HDFS file system. As of now, just to take it as a randomly. Okay, Naveen? Is that clear? Okay, perfect. Okay, so now let's discuss about our HDFS file system size. Okay, so now 10 GB of data, 10 GB of hard drive, 4 GB of RAM, 4 core processors is there for each computer's configuration. So now you have to tell me what is my entire Hadoop cluster capacity in terms of hard drive, in terms of GB, in terms of core processors. What is my entire Hadoop cluster size now? Simple, right? If yeah, five, not five. I'm not talking about how many nodes I have in my cluster. I'm talking about my entire hard drive capacity as a whole together. Since I'm putting all 5 computers together, what is my hard drive capacity? What is my RAM capacity? What is my core processor capacity? Okay, Likita said 40 GB hard drive. Can you tell me why 40 GB, Likita? Uh, 50 GB, that's perfect. Okay, 40 GB and also fine, but if you are able to give me the answer, that is fine, Likita. Why 40 GB you came up with 40? Just speak out, okay? You are not here to say what you know already, okay? You are learning here, okay? You can say whatever you want, okay? I'm okay with that. Don't feel anything bad, okay? So, okay, I thought 4 nodes only. Yeah, that's perfect. Okay, that's fine. Yeah, that's all. If you are giving answer, that's fine. Okay, this is a 5 node cluster. Okay, 5 node cluster. So 5 into, people who gave 50, that's good. Okay, 5 into 10 GB. So it's coming up 50 GB. 4 into, 5 into, what is that? 4 GB RAM. Okay, so it's equal to how many GB? 20 GB RAM. This is RAM actually, and this is HDD hard drive. And the same thing, core process. How many processes I can go at a time? 5 into 4 equal to 20 core processor. Okay, this is fine. So this is what your entire Hadoop cluster capacity. This much maximum, this much of data you can store in your Hadoop cluster. Okay, maximum this much of data you can store in your Hadoop cluster. Okay, this kind of one computer. Just think as this kind of one computer. But when we talk about storage wise, what and all are coming into the picture? Whenever you wanted to store your data, what nodes are acting really? Only your data nodes. Data nodes only. So now you have to tell me what is my storage capacity of my Hadoop cluster. You have to leave your master now, because master is not the one which is going to store your actual data. Excellent, 40. Okay, because 4 into 10 only, because I'm not going to use my master node capacities to store my data in this computer. Okay, we can discuss that. There are some exceptions, we can discuss that one, but as of now your data nodes are the one which is going to store your actual data. That is the reason 4 into 10, 40 GB of hard drive you have as a whole. But so let's discuss on our HDFS. Okay, HDFS is not a combination of all your data nodes hard drive, or HDFS is not a combination of all your data nodes configuration. So whenever I say here, you are saying here probably if you are going with the example 4 into 10 GB. Let's talk about only hard drive. Okay, 4 into 10 equal to 40 GB hard drive. No, it's not the, is not the way we have to say my whole HDFS capacity is 40 GB, because 40 into 4 into 10 GB of each hard drive, I'm going to say 40 GB of my HDFS. 40 GB equal to my HDFS capacity. Okay, HDFS Hadoop file system capacity is 40 GB. No, that is not the way we have to say. Now I'm going to introduce that concept. Why we should not say that one? Let's discuss that one. Okay, this is my hard drive. Okay, this is my, just concentrate here, this is very important. Okay, this is very important, and you have to understand very carefully here. This will be lot many interview questions will be involved here. Okay, so this is my hard drive. Think this is a hard drive, one computer hard drive. Okay, we are going to come up with only one computer. Later on we can calculate that one for we can calculate that one for whole computers. Okay, so this is a hard drive. Okay, so this is one computer's hard drive. Okay, this computer, in order to make use of this computer, in order to make use of this one computer's hard drive, okay, what you have to do? You have to have a operating system on your computer, right? You have to have an operating system, then only you can make use of that computer, you can work on that one. Operating system is the main thing. So in this case, whatever operating system that is going to take the space, this 10 GB RAM, 10 GB hard drive. Okay, this is 10 GB hard drive. So out of 10 GB, I am going to allocate probably 2 GB for my OS, Linux operating system probably. Okay, Linux or Unix, whatever it is. Okay, so I have allocated 2 GB of hard drive for my operating system, because without operating system I cannot make use of that computer for my use. Okay, so that is the reason you have to have an operating system on machine. Okay, out of 10 GB of your hard drive, 2 GB you have allocated for your your operating system itself uses 2 GB. Okay, not something like that allocated. Okay, next, what is our Hadoop cluster? Hadoop cluster is nothing but you have to have a Hadoop software on each and every computer. Okay, following, right? So in order to install your Hadoop software on each computer, that is going to take some amount of data, some amount of space. Okay, this space for your Hadoop framework. Okay, this space for your Hadoop software. Let me try a Hadoop. Probably 1 GB I am going to use for my Hadoop software. Okay, now rest is how much is left for my, out of my 10 GB of hard drive, how much is left? How much is left? 7 GB. Perfect. 7 GB of hard drive is there. Okay, good. 7 GB of hard drive is left now. So this 7 GB, can I allocate everything to my HDFS file system? No. you cannot directly allocate this 7 GB of hard drive to your HDFS file system. Why? Because you have to have this is your HDFS file system, for example, and top of this one you have to leave something for your local on your each and every computer also, because there might be some temporary files that you have to store in your local computer, okay, or something like that. You have to, some of the configuration file I have to store in this computer, okay. So all these things you have to make sure in your local computer also sometimes, okay, or sometimes you have to copy some data into your local computer, then you have to move that data into your HDFS file system. To accommodate those kind of tasks, what they do is they are going to, again, out of this 7 GB of data, how much GB I am going to give for my HDFS file system and how much I am going to use for my local file system. So out of this 7 GB, probably 5 GB of data I am going to allocate to my HDFS, okay, and rest 2 GB I am going to allocate my local. So okay, whenever you are installing your Hadoop software on your computer, on your data nodes or on your master node, whatever it is going to ask you, whenever you are enabling your data node services on that computer, it is going to ask you, hey, I am seeing total 7 GB left as of now. How much do you want to allocate me for your HDFS file system? How much is going to leave for your local? Okay, what is the purpose of having local? When you have, okay, you can say, oh, why you have to leave the local space for on each computer, Shiva? Why can't you give everything to your HDFS itself? Yeah, there are certain situations where in between the process you have to store some temporary files within your local file system, or you have to have some configuration files within your local file system, or you have to have some softwares to be installed, or you have to copy some data from external world into one of your data node into your local computer, then you have to move that data into your HDFS file system. These are the certain situations where you have to have some local space in each and every computer. So in that case, so how much you have given out of 7 GB left over, how much you have given for HDFS file system? 5 GB, remaining 2 GB you left for your local. Okay, so now whatever this one, how many computers data nodes you have? 4 data nodes. So now you have to tell me how much of HDFS pool you have created. This one, how much is your HDFS now? This is HDFS pool. Okay, this is HDFS pool. How much? With 25 when we are talking about only HDFS. HDFS is nothing but only data nodes we have to talk about. Okay, so 4 into perfect 4 into 5 equal to 20 GB hard drive, which is your HDFS file system. So your HDFS file system is how much? What is the capacity of your HDFS file system? 20 GB. So going forward, if someone is asking what is your HDFS file system, you should not say it is a combination of all your data nodes hard drive. It is a contribution of your n number of data nodes. Okay, what I mean by contribution, I am not going to give everything whatever I have out of my each data node. I am going to contribute some of the space that I have out of my hard drive. Here in this case, I am giving 5 GB of space out of my 7 GB left over. I am going to give 5 GB to my HDFS file system, remaining 2 GB for my local. Okay, so are you clear with this? So this one, with this one, this whatever 20 GB we have arrived here, we'll be calling this one as a DFS space, DFS capacity. What is DFS? Distributed file system capacity. What is your Hadoop DFS capacity if they are asking? This is a contribution of n number of data nodes will be DFS capacity. What is non-DFS capacity here in your Hadoop cluster? What is non-DFS? Non-DFS is 2 into multiplication of 2 into 2 GB you allocated for your local. Okay, 4 into probably 4 into 2 GB equal to 8 GB. 8 GB is your which is a local one, which is not related to DFS, non-DFS, which is local. This is very, very important. So how did you come up with the HDFS pool here? You have to understand very clearly. So this is out of 10 GB of hard drive, my operating system has used 2 GB, and on top of that my Hadoop software is there as a 1 GB. Remaining 7 GB, I have allocated 5 GB for my HDFS and remaining 2 GB for my local. So since from each computer I got only 5 GB for my HDFS file system, since I have enabled 4 data nodes as my 4 computers as a data node services. So 4 into 5 GB, it would be 20 GB of hard drive, which is my 20 GB of HDFS file system I have an overall. So only I can accommodate 20 GB of space in terms of HDFS file system, which is your DFS capacity. What is your DFS capacity here? 20 GB distributed file system. What is non-DFS? It is nothing but whatever you allocated for your local, that is your non-DFS. So any questions so far? It's questions time.
Yeah, Shiva.
Yes, Navin, go ahead.
When we are not storing any data in master node, why we have to allocate 10 GB for that?
Oh yeah, that we are going to discuss very thoroughly. Name node is not the small one. I mean, master node is not the small one. Master node is going to do many tasks. We are going to discuss one by one, Navin, but it's just too early. But let's concentrate our data nodes now. Let's learn first of all, as we go in the sequence. Let's learn first about data nodes. Okay, we will come back. Don't worry. After the completion of our discussion, definitely you are going to know answer for that question. Okay.
Shiva, if the data nodes were completely filled with the data, then don't we have a system that the space is limited?
Yes, that is called scalable. Scalable is a issue in your traditional RDBMS or traditional system, but whereas in your Hadoop framework, what you can do, you can just simply add one more computer here. Simply add one more computer here. Because this is a commodity hardware, this is a cheap in hardware. As you go on, you can add more computers to your cluster.
Okay.
That's all.
So
there is no use at all.
So the Hadoop does not have any limited space?
Yes, there is no limited space at all as long as you are able to add your computers. But you have to upgrade some of your masters also, because your master is the one which is going to maintain this whole information that we are going to discuss. But as of now, in terms of scalable, in terms of adding your data nodes, there is no limitation also. And right now in our production grade environment, Yahoo is running 45,000 machines. They have clubbed 45,000 machines together and they are using their users' data to come up with their results. 45,000, not in 100, 45,000 computers.
So for every few data nodes, we will have a new master node for it.
That is not the concept. We are going to have only one master. I mean, we will be having one master node, but master nodes task also will be divided. That we are going to see as we go on with our classes. Okay, as of now, think like master is the one which is going to get the work from the client and assigning it to your data nodes. But master node task also will be decided or divided across multiple master nodes. We will not be having only one master node. We will be having more than one master node. But it is too early to introduce that one. But we will be having more than one master node. You have to, I remember.
So when you say, sorry.
Yeah, go ahead.
So when you say scaling, so how does that happen? Horizontally or vertically?
Horizontally. This is what horizontal way, right? This is the horizontal way. Vertical way, we have seen the issue. Probably, I think I could have missed your demonstration, but in my demonstration, I would have demonstrated clearly. Vertically, you cannot really increase your capacity this much. Horizontally, how much I want, how many data nodes I want, I can add horizontally. As I go on, I can add on like here. Okay, that is the reason 45,000 computers I put together.
Okay.
Horizontal scaling, it's not a vertical one. Vertical one, at certain point you cannot really scale. I mean, it's not scalable really. At certain point of time you are going to reach the peak level and you are going to stop there. Hey, I cannot go more than this one. Questions? Good questions. Any more questions? Okay, so any more questions on this DFS and non-DFS, this HDFS pool? Any questions here? Okay, so let me move on with my next
I have one doubt.
Yeah, go ahead.
So you said there is a non-DFS thing, right? So is there any like dedicated memory for non-DFS? Like, okay, if I go to this data node, like, does that non-DFS thing vary from one data node to another, or it's the same thing for every data node? And how do you get that memory?
Perfect, Kirti. Is that Kirti? Kirti only, right?
Sudha. No,
Sudha. Okay, Sudha. Sorry. Yeah, excellent question. Yeah, that's what I can talk one more topic also here. So here we talked about homogeneous computers only. When I say homogeneous, we are going to have a same configuration across all your data nodes. Okay, that is not mandatory. One computer you can have 10 GB of hard drive. One more data node you can have 1 terabyte of hard drive. Okay, 1 terabyte of hard drive. Okay, so you can have heterogeneous computers also. What I mean by heterogeneous, each computer will be having its own configuration. So whenever you are going to install Hadoop software on 1 terabyte of hard drive, after leftover probably 950 GB it is there, probably just rough calculation, 950 GB is there. Whenever you are installing your Hadoop software on this computer, it says, hey, I see 950 GB of hard drive is there, how much do you want to allocate? So for example, this computer, only this one. So here I'm going to allocate 900 for my HDFS file system. So this 900 will go into this pool. Okay, 900 will go into this pool, and remaining, if we go with our thumb rule example, remaining 40 GB from this computer plus 900. So total, how much your HDFS pool became? 940. Only 940. Okay, 940 GB. Only 900 GB of space came out of only single computer. Rest from remaining 4 computers, you got only 10. You got only 5 out of each computer. Okay, I'm sorry, not 40, 20. 20 plus 900, 920 GB. 920 GB of your HDFS pool became. So now you can think now on each computer you can have your own HDFS space and your own local space. Whenever you are installing, it will be asking how much do you want to allocate for your local out of this computer, how much do you want to allocate for your DFS, which is your HDFS. It's not something like that. Always you have to have a unique one across your all computers. On one computer you can have, in our case, 2 GB, and in this computer you can see I have allocated 50 GB for my local and remaining 900 GB for my HDFS. It differs. It differing, right? Differing here 900 GB for HDFS and 50 GB for local in this computer, and in this computer only 5 GB for my DFS and remaining 2 GB for my local. Sudha, did I answer your question?
Yes, but when you told heterogeneous, I got confused between again. When you say heterogeneous, one having small and one having big configuration, doesn't that come under scaling up?
No, why it will come under scaling up? I mean, probably you might be thinking, yeah, one which is having 1 terabyte of hard drive, this will be having super fast computer, and this is going to process this is going to complete its task more quickly than others. Yeah, that may be, if you are getting that question in your mind, that is perfect. But when we are going to divide your RAM, we are going to divide in such a way that each piece are, could you please go on mute, people who are not speaking? Okay, each piece is going to have a same capacity that we are going to discuss later, Sudha, but as of now you have to remember, I don't want to confuse you again, but that is not the issue. Okay, why, how, we are going to see that one probably in the next classes when we discuss about RAM part, when we are going the same way. How we have divided our hard drive, now we are going to divide this RAM also. Okay, this RAM, when you process your data, RAM will come into the picture. When you store your data, your hard disk will come into the picture. So we have discussed only HDFS file system. When we discuss about map reduce, that part will come into the picture. That time you should able to get your answer. Okay, so don't worry, no, that is not the case. Whenever you have a different configuration for each computer also, you will not be having any issue at all. It's going to be the same process.
Okay, thank you.
Okay, that is one thing. The next thing is, okay, probably let me discuss with this point. After that I'm going to introduce that one. Okay, the homogeneous and heterogeneous in terms of configuration, in terms of operating system also. Okay, so now in our office grade environment, we have to use RHEL as a operating system, which is a Red Hat Enterprise Linux. This is the Linux flavor of operating system. It's a paid one. People are going to use this one because they are going to get again support from this Red Hat community. Okay, if something is going wrong with their operating system, they are going to come and help you out. Why went wrong? What is the issue with that one? Okay, so but in order to make use of our free software, okay, the CentOS came into the picture. CentOS is same as your RHEL. Okay, you are going to see the same commands, you are going to see the same flavor, you are going to see the same concept. But whenever you have any issues with that, you are not going to get any support out of your RHEL. It's free to use this software. So generally for our development purpose, we'll be using only CentOS instead of paying for your RHEL. You are going to get everything same. The only difference here is whenever you have any issue, you have to rectify with your own, with your CentOS. But whenever you have any issue with your RHEL, you are going to get the support from RHEL people. That's the only issue. The same concept what we have just had between Apache Hadoop and distributions. Whenever you go with the distributions, you are going to get the help from your distribution people who is like Cloudera or Hortonworks. But wherever this RHEL, whenever you go with the RHEL, you are going to get the help or maintenance kind of thing. Okay, maintenance will be done with the RHEL people community. But whereas if you are going with the CentOS, you have to maintain with your own efforts. Okay, that is one thing. So whenever you are going to have your computers putting together in Hadoop cluster in our office grade environment, okay, recommended you have to use the this operating system. Red Hat Enterprise Linux operating system will be there on each and every computer. Okay, so okay, provided now with that concept, it is not the mandatory rule. What I mean by mandatory rule here is, in this computer I can have Red Hat operating system. In this computer I can have iOS operating system. In this computer I can have Windows operating system. Still I can connect them within my Hadoop cluster. Are you clear? So here in terms of capacity, in terms of configuration, in terms of operating system also, I can have a individual operating system on each and every computer. Still I can connect them. I should be able to compute my computational techniques using my Hadoop framework. Okay, Hadoop framework is giving that luxury indirectly here. Okay, so this is a CentOS. I mean most of the 99% for development purpose we are going to use the CentOS only, is the operating system. Okay, are you clear with this one, why we have to use CentOS and all? Any questions here? Okay, so let's move on with what is daemon. Do you know anything what is daemon here? In computer language, what is mean by daemon? Any answers is welcome. Okay,
background a process which runs in background continuously, like every 5 minutes or every 2 minutes. Example, yes, for checking a file, incoming file, so it keeps on checking.
Yes.
Executing.
Yeah, that's good. I think you said 100% that every 5 minutes or not every 2 minutes. It will be always continuously will be running. If you're not running that one, you're not listening. It's kind of listener. If someone is sending any request to you have to respond back. That is kind of listener. So it's a process that will be running always in the background. Whenever I say process, it's a program. It's a program. Daemon is nothing but it's a program that will be running in the background always, not every 2 to 3 minutes. Okay, always. It's a program that will be running always in the background, that will be calling as a daemon. So we have some daemons also in our Hadoop. Okay, we are going to discuss one by one what is that. Okay, so we have certain daemons in our Hadoop cluster. We are going to discuss what and all them. We are going to discuss that one. Okay, so as so far we have seen
are they like similar to threads in Java, like daemons?
Yeah, daemons are kind of threads in Java, but yeah, concept wise could be the same thing. But here in Hadoop wise, we are going to have a daemons to keep up your Hadoop cluster and running, and you are able to make some of the operations on top of Hadoop. It's not threading. Threading is the thread concept is completely different in Java, but here this is kind of process only. It's not going to do anything. It's always listen and it's going to respond back whenever it gets the request. Okay, so let's go on and discuss with our daemons. Okay, so daemons, we have total 5 daemons that will be running in our Hadoop cluster. Okay, 5 daemons. Okay. Okay, probably let's start with data node. Okay, you know data node and name node, secondary name node. Okay, job tracker. Okay, just don't get confused what is all this means. We are going to discuss very thoroughly this one, task tracker. Okay, so let's discuss one by one. What is data node? We have discussed already. Data node is nothing but it is a node which is going to store your actual data. So you know about that one. So in order to make use of your data nodes within your Hadoop cluster, you have to make sure your data node daemon is up and running. Okay, data node service is up and running. So we will be calling daemon as a service also in our Hadoop cluster. Service also we can call as a data node service or Hadoop services or HDFS services. We are going to discuss that one. Okay, what is this name node? Okay, so far name node is a master node actually. Whatever we discussed so far, whatever is discussed your master node, right? Master node is the one which is going to get the work from the client and going to assign the work to the server. The same way here, master node is the name node is the master node. Name node is the master node which is going to make sure about your data nodes structure, which is going to make sure where and all your data nodes are there, how much space it is there, and how much space already left over in out of your each data node. Those kind of information will be there in your name node. So let's discuss few more points about your data node, name node. Okay, so name node HDFS file system. What I mean by counterpiece of your HDFS file system here is your heart. It's for your entire HDFS file system. Your name node is a kind of heart. Okay, what I mean by that one is, let's discuss one point. Do you know anything about metadata? What I mean by metadata here?
It's like an index file, like index page of a book.
Yeah, that's correct. That's correct. Data about data, that's correct. It's kind of index, that is correct. Indexed one is the right word that we will be using in our Hadoop framework, but data about data also is the correct one. Data about data, information about the data is something like that, metadata. So in our example, if you take our first example, temp.txt file, we are saying that the file name is temp.txt. It is having 100 MB in size and the block size is as a 64 MB, and we are going to store in what data nodes and what are the permissions we have, and where and all we have stored these different blocks, those place. Okay, so let's take this example only. Okay, so this is a kind of metadata for temp.txt file. You can see here So here is my file name and total file size, and this is a 64 MB is a default block size for this file, and replication factor we'll come back to this one, and we are going to see the replication factor also for the in that metadata for that file, and when you have last modified this one, and what are the user permissions. So who and all can access this file whenever I'm going to place this temp.txt file in a HDFS file system, and who is the owner of this file, and that owner belongs to what group. So this kind of information you have to store for each and every file whenever you wanted to copy that file into your HDFS file system, into your Hadoop cluster. Clear? What is metadata about your file? Metadata includes this. This is the information about your metadata. Your file name, your total size of that file, and what is your default block size when you are trying to copy that file into your HDFS file system, and what is your replication factor for that file, and when did you modify that one, or when did you copy that one, and what are the who and all can access that file, permissions indirectly, and who is the owner, and that owner belongs to what. This is the information that you have to maintain in your metadata for each and every file. Okay, clear on this one? So this is about metadata. So here this metadata will be stored in your name node only. Okay, your metadata will be stored in your name node only. So what I mean by that one here is, in our example, you can see here. So whenever I'm trying to copy this data into 100 MB of data into 100 MB of data into my Hadoop cluster, okay, name node, here is a master node. Okay, think like here is a name node. Name node is a called what? Master node. Okay, so in order to copy this data into my HDFS file system, I have to maintain this data. Whatever data we have just discussed, we have to maintain this data. Probably let me keep here. Okay, so here I have to maintain this data. I have to maintain this data into some file. Okay, into some file. This file will be maintained in this my name node computer. So metadata is a data about your data, information about your file. That data will be stored in your name node. Now today, for example, here in my previous example also, okay, we have just copied here B1 here, 100 MB, B2 here, and now your name node has stored this information. A B1 I stored in the data node 1, and my B2 block I stored in data node 3 for my temp.txt file. So this information is stored in this metadata, and it is stored in the name node. Whenever I wanted to process this 100 MB temp.txt file data, tomorrow I am going to run some jobs, or tomorrow I am going to view that file. So in that case, what I have to do, my request has to go into my name node. Name node is the one which is going to search in the metadata file saying that, hey, I got this request, temp.txt file is there, can you tell me the information about this file? Okay, so your name node is going to search your entire metadata. It's going to find out this string, okay, this string information for this particular file, and it's going to say, hey, this is the block size, when and I stored, and those information will be found, and your job will be routed here and here. Are you clear about now metadata? What is the purpose of name node? Okay, name node is a master node where it is a counter piece of your HDFS file system. Why it is a counter piece of HDFS file system? Because your metadata will be stored in your name node. At any point of time, if your name node is going down, even though your all data nodes are up and running, whenever you as a client is trying to send the request to your name node is no more, and your request is your request will be going and sitting ideally saying that it is not finding any information because your name node is down. It is no where it has to go and search for your temp.txt file. This information is lost actually because your metadata will be stored in your name node only. So that is the reason we will be saying always name node is a counter piece of for your HDFS file system. Why? Because your entire metadata of your HDFS file system will be stored in your name node. So that is the reason. Even though Hadoop framework is recommended to have, or Hadoop framework can go with the commodity hardware, which is low reliable hardware, but whenever you are choosing your name node, whenever you are choosing as a master node as a name node, it is always recommended to go with the enterprise hardware for your name node alone. Okay, I mean your master node, in this case your master node, you will be having more than one master node in your Hadoop cluster. Your master node, whenever you go with the name node, this name node should always go with the enterprise hardware, because even if you are not going with your enterprise hardware for your name node, if this is going down because you are using a commodity hardware here, so your entire Hadoop cluster is useless. You cannot use this entire Hadoop cluster. That is the reason you have to go with the enterprise hardware. But you can ask me, why can't I have this more than one replica, and why can't we store this one? That we are going to discuss thoroughly, but as of now, no. Okay, name node is the one which is going to store your metadata of your HDFS file system. That is the reason you have to have a enterprise hardwares. You have to have enterprise high reliable hardwares for your name node. Is it clear? What is the name node? Yeah, go ahead.
Like, who is going to say which block of data is where can I go and find? So this data node is performing task on this block of the file. So who is going to store that index thing?
In terms of processing wise, that I am going to discuss. In terms of storage, your name node is the one which is going to have. In terms of this block is there here and this block is there on data node 3, that information will be again where you are going to store your metadata, your name node. So indirectly your name node is the one which is going to maintain which block is there in what data node. Those kind of information will be indexed in your metadata only. In terms of processing wise, what data node is processing what block, we are going to discuss when we discuss about job tracker. In terms of storing wise, your metadata is the one which is going to have this kind of index. Okay, the next daemon is, and we have 3 more minutes, probably I will take 2 more minutes extra. So let's complete this daemon so that freshly we can start on next discussion. Okay, next slide. Okay, what is secondary name node? So as you know, secondary name node, the name suggests, is a backup for your name node. So it's not completely 100% backup, but we have to say this is a backup. Why it is a backup? Whenever you are whenever your name node crashes, you have to recover your data, whatever it is there in the secondary name node. That is the reason we are going to always make a one copy of your metadata in your secondary name node also. It's not completely 100% backup, but think that secondary name node also is your master node, okay, which is going to maintain as a, which is going to act as a backup for your name node, which is going to backup, it is going to act as a backup for your primary name node. Okay, so you can recover the metadata whenever your name node is crashed. Okay, that is the secondary name node daemon. It's also daemon. You have to keep this one up and running in order to make use of some of the facilities that you have in your Hadoop cluster. What is the job tracker here? So far we have seen only copying the data into your Hadoop cluster. Okay, so far we have copied temp.txt, abc.txt, all those files only we have copied. But what if I wanted to process the temp.txt file? Okay, so that will be taken care by your job tracker. Job tracker is the one which is going to manage your map reduce jobs. Whenever we talk about process, remember I told you we have to talk about map reduce. Whenever you talk about storage wise, you have to talk about HDFS in your Hadoop framework. So whenever you have submitted any job to process on top of your data, whatever exists in your Hadoop file system, first what you have to do, you have to submit your job to the job tracker. So this is again master node. Job tracker also is a master node. Job tracker also is a master node which is going to manage your entire map reduce jobs within your Hadoop cluster. Okay, now you can so think like whatever you said, like which job is doing what, your job tracker is the one, which data node is processing what block, that is going to taken care by your job tracker. Your job tracker is also should be kind of enterprise hardware, because if this is going down, if all are up and running, even though your metadata, your name node is up and running, your job tracker is going down, in that case also, whenever you submit any job, if that is down, you cannot perform many tasks on your Hadoop cluster. That is the reason your job tracker also should be kind of your enterprise hardware. Master node, you have to have an enterprise hardware. So what is the task tracker here? The next daemon is task tracker. What is task tracker? Task tracker also is a daemon. Okay, task tracker also is a daemon which is going to do your actual task. Okay, which is going to do your actual task. What I mean by actual task here is, so whenever you submit any job to perform this 100 MB of data, you are submitted to the job tracker. Okay, job tracker will be there. Job tracker, as you know, is a master node. It will be there here. Okay, so you have submitted the job to here. Okay, this job tracker is the one which is going to assign the work to your task tracker. Okay, task tracker will be running on each data node. It is taking care from each data node side. Okay, task tracker is the one which will be running always from each data node side, and it will always keep listening to your job tracker, saying that, hey, whenever you wanted to assign the work, you can assign. So job tracker is the one which is going to assign the work to the task tracker. Task tracker is the one which is going to do your actual task. Job tracker is not going to do your actual task. Job tracker is going to do what? It's going to assign the work to the task tracker. Task tracker is the one which is going to perform your actual task. So now task tracker is what? Is a slave daemon. It's a slave service here. Okay, slave. Task tracker is also slave service, and your data node also is a slave service. So here, to store your actual data, we are going to use a data node. To do your actual task, you are going to use a task tracker.
Should I think like then job tracker is one kind of a process which runs on the name node, and task tracker is a kind of process which runs on the data node?
The second point is correct. Okay, let me draw now typical diagram how it will be there here. Okay, so far we have seen these three daemons. Okay, let's go with this one. Okay, these 4 data nodes, and this I have 4 data nodes I have put together. Okay, and here I have 3 master nodes now. Okay, 3 master nodes recommended in typical office grade environment: name node, job tracker, secondary name node. So these has to go all in a different computers. Okay, this is data nodes, because name node has its own task. I mean, name node has to do many things for your HDFS file system. If you are putting this, I mean, you can still do that. Name node and job tracker can go with the same computer. There is no harm at all. But if you both are doing, and both are, if your one computer is, you are going to enable for name node as well as for your job tracker. At that point of time, one computer only has to take care of these 2 tasks. So that could be some of the bottleneck for your that computer that may go down. Okay, that is the reason always recommended. Job tracker will go with one computer, name node will go with one more computer, and secondary name node has to go with the one other computer. Why? Because it's kind of backup. If both are going to maintain in the same computer, if this computer is going down, there is no use of maintaining the backup in the same computer. Okay, think like in one computer, if you are maintaining 1 copy or 100 copies, there is no use at all. If that computer is crashed, you are not going to recover the data. So that is the reason you have to have 2 computers at least as a master nodes. One is for your name node and job tracker. Both can run at the same computer. For different computer for your secondary name node, you have to go with a different computer actually. Okay, this is what. And also the task tracker, like you said, task tracker will be running on each data node. It's kind of figure listener. Okay, it's also job. Yeah.
How this job tracker will come to know to which task tracker should go and get the data?
Yeah, that we are going to discuss when we talk about read and write operations in your MapReduce. That is too early. Okay, that we will discuss and read and write operations whenever you submit any job. Okay, whenever you submit any job to the within your Hadoop cluster, first and it will go to the job tracker. Job tracker is the one which is again contacting to your name node. Name node is having the complete information, block report information and all, because it's having the metadata. So it's going to get the report back to this one. Okay, it's a high level. Okay, if it is confusing, just leave it. So once it get back the report, okay, this is the my file name, this is the total size, and this is the number of blocks that I have, and this is where I have stored each block. So once your job tracker gets that information, it's going to assign to those respective data nodes. Okay, this is high level, but there are a lot more discussions will be involved in that read and write operations of your MapReduce. But as of now, whenever you submit any MapReduce, it will go to your job tracker. Job tracker is the one which is going to talk to the name node. Name node is having the metadata information that will be given back to your job tracker. Job tracker again will connect back to the task tracker and is going to assign the task to that. Task tracker is the one as again work on that data node which will do the actual task.
Does the job tracker take the you have said that it will contact with the task tracker, right?
Yeah, finally for assigning the task, job tracker will contact to the task tracker to assign the task.
So how does the job tracker know how to assign the job to the only this particular node?
Yeah, that we can we talk about when we talk about block report. Block report is the one which is going to decide that one. Okay, block report is the one which will be sending from data node back to name node.
Okay.
Okay. So yeah, Naveen is asking what is the master nodes and name node. Okay, master nodes and name nodes are not any difference. Okay, this is one master node, this is one master node, this is one master node. Master is nothing but it's kind of manager. It is going to assign some task to your under you whatever is as kind of people under you. It's kind of manager. Yeah, there is no difference between master and name node. Name node is a master. Name node is a master node. Job tracker is a master node. Secondary name node is a master node, which is nothing but it's going to assign some of the tasks to under the people who are having under him. Clear, Naveen? There is no difference at all. Okay, master node, name node is a master node. There is no difference between master node and the name node. Name node is a master node. Job tracker is a master node. And secondary name node is a master node. We have some more master nodes also that we are going to discuss. So it's the recommended way for all your master nodes, people in office grade environment. Okay, we are done with 8 more minutes extra. Sorry about that. Okay, so Naveen is asking, can we have what is that? Why it's not coming? Okay, so can we have a name node and job tracker in one master node? Yes, obviously we can have. Name node and job tracker can you have in the same computer, but as you know, name node as itself having more tasks. So when you are having both in the same computer, it's kind of more bottleneck for that computer that may go down anytime. Okay, so okay. Thank you all, and that's all I have for the day. Any more questions from the beginning? We have completed. We have almost discussed it 2 hours, and tomorrow on Monday, please try to join again. We are going to next 2 more hours, and after that, on the day only, you have to bear 3 hours of class. Okay, because in your evening hours, I'm going to cover 2 hours, and again the next day, a bit per you probably in 2 days, but the next day in your morning, I'm going to cover 1 more class. So from that, your Monday morning class would be your regular class. Going forward, you are going to have the regular class only in that one. Okay. So in next 2 hours, whatever I have covered in my regular batch for 3 hours, I'm going to cover for you. So we are going to continue in that. There are 3 more people are there in that batch. So we are going to cover with that. Okay. Is that clear? All are okay with the timings and all, right? Okay, the timings would be, the regular batch timings would be Monday to Friday, 9 p.m. IST, the class will start and it will end by 10:15, something like that. So which is your morning hours. If you are in central time, probably you have to convert that one into your timings. Okay, IST, I think all know about IST timings. So IST 9 p.m. IST. in the evening time, PM actually. Okay. Any questions? Yeah. Monday we have class at the same time. Okay. Monday will be having the class at the same time, 7 to 9 a.m. Okay. My timings. If we are able to meet 6 a.m. that is also great. Yeah. I can meet at 6 a.m. also. Are you available at 6 a.m. on Monday? I mean 1 hour before. How we met today? Just 1 hour before this. Whatever time we met today. Are you available? If you all are available, that's well and good. I can complete 1 hour ahead and I can. Excuse me. Go ahead.
Yeah, that will be fine for me.
Oh, good. 6 a.m. IST is fine on Monday. Okay. Any more? If you are not speaking, probably I will take as a granted. Please speak out. Okay.
Before that, I need to discuss something about you. I call you and discuss about. I want to know what are the concepts I have to learn in order to learn. I mean, Java concepts I have to learn in order to learn Hadoop. Okay.
Yeah. If you want to become the tutor, you have to learn all components, whatever we are going to discuss. But as a developer, Hadoop developer, if you want to become if you don't want to become a trainer, I mean, obviously people are going to become a developer. Like me, if you want to become, probably you have to learn all echo components that we are going to discuss. Okay. If you want to become a Hadoop developer, probably one of those components, you have to know concepts wise. Okay. People who are, I mean, within a team, if you go and work for any organization, you are not supposed to work in pig, high, woozy, HBase and all. You will be asked to work only in only one echo
No, sure.
component. So
I'm not asking about the Hadoop concepts. I'm asking about Java concepts.
oh, Java, I'm sorry. You have to know core Java concepts alone to start with your Hadoop development. Only core Java. And again, in specific to complete, not complete. If you want me to talk about again in core Java, probably you have to know file handling. You have to know how to manipulate the data within the file and how to read the data within the file, and on top of that, collections. Okay. On this topic, on top of that, collections are main important. Okay. Only these 3 topics also you can learn. It's not a big deal. I mean, because people who knows about Java are very less in the market. That is the reason people are slowly going away from the map reading section.
Okay. So hooks and collections are fine, right? No need to learn multi-threading.
No, not multi-threading and all those concepts we are not going to use. No.
Okay.
Collections, by the time you learn collections, you should be able to understand everything. If you can start with classes and end with collections, that's all.
Shiva? Yeah, if you want to be an Hadoop developer, can we choose whatever we want, like Pig, Hive, or HBase? Or it depends upon the company?
That's what I was trying to say. If you want to become a Hadoop developer, you should be the master in one of the echo component. It can be Pig or Hive or HBase.
So it depends on our choice.
Yeah, it depends on our choice. Based on your skill set only, you are going to get the job. Okay. Based on like people who wanted in HBase, they might be approaching you. But you are going to keep all together. Okay. It's not something since you only learned HBase, you are not going to keep rest of them in your resume, because we are going to discuss each and everything. You have to learn basics and then just choose one and become master in that.
Okay.
Okay. Okay. Any more questions? Okay, then I think we are done.
You are going to cover that. Shiva, you are going to cover that Java session, right?
Java session. Do you want Java session?
Yeah.
Okay. Probably probably I have my task. Probably we can cover that one. That's not a big deal. Probably within 2 to 3 classes we can cover. That's not a big deal. Okay.
Okay. You know, like Google.